So, as part of the PowerPoint, I also introduced you to the idea of post hoc tests. And remember that post hoc tests are tests that follow an ANOVA analysis that allow us to identify where significance is occurring specifically between the groups. If we were calculating this particular ANOVA through a hand calculation, we would get to the end where we have calculated an F statistic, we compare it to a critical F statistic, and we make a determination. If there's no significance for an example, a hand calculation, if there's no significance, then that means there's no significant differences between any of the groups. If we were doing a hand calculation and determined that there was significance, the hand calculation test by itself does not indicate where specifically the significant difference exists. And so the question becomes, is the difference between those with a high school diploma versus graduate school? Is it between those with no high school diploma and associate's degree or certificate? Or is it between all of them, right? And any kind of combination of groups that you can think of. So the post hoc test will allow SPSS or indicates to SPSS that we want to make that comparison. Within this post hoc button, you're going to find a variety of different types of post hoc tests. We're going to select this 2 key. We don't make any other changes here. We'll select continue. There's also another piece that we need to modify within the options tab. And within this tab, we're going to select this descriptive button. This is going to ensure that when SPSS produces the results, that we are going to see what are the averages and standard deviations for each of the groups independently. We'll select continue. We'll leave all the other options as default, and we'll click OK. When you produce a one-way ANOVA, you're going to see a minimum of 3 tables. You'll also have this homogeneous subsets table. This is a table number 4, but I'm not asking you to include this in your assignment. The 3 tables that you need to make sure you include for each of your analyses for your one-way ANOVA are going to be this descriptives table, this ANOVA table, and this multiple comparisons table. So this descriptives table is doing, as I mentioned, it's giving you the average. So remember, we're relating this back to our research on the topic of, does mother's education level affect GPA? So the average GPA of students whose mothers have no high school education is 2.99. The average GPA for students whose mother's education is a high school level is 3.24. So on and so forth. Now, if I were to ask you, are there actual mathematical numerical differences between each of these means? Of course, you would respond with yes. But remember that the purpose of this test is to determine whether or not those differences are significant or meaningful. This descriptives window is also where you are going to find your standard deviations. You want to make sure you understand how this descriptives table is used, because these components are going to be necessary as far as writing the APA formatted results section for a one-way ANOVA. So please make sure that you are, navigating back through the PowerPoint when you're unsure about some of the formatting or some of the ways in which I want you to describe these tests for the reporting results. So this is your descriptives table. Down here is your ANOVA table. And this is the table that are the specific results of the ANOVA test itself. We have, remember from the hand calculation, we know that it's possible to calculate some of the squares between groups, within groups, and then a total. We could do this by hand. We can calculate degrees of freedom between groups, within groups, mean of squares between groups, within groups. This is our F statistic. And this is our significance level for the test, the overall test. This significance level is what you need to compare against 0.05 in order to determine significance. If this significance level is less than 0.05, your test does have significance. If this is greater than 0.05, your test does not have significance. In this particular case, our significance for this ANOVA is less than 0.001, which means that there's a significant difference somewhere in here, okay? Between this descriptives table and this ANOVA table, we don't yet know where that significant difference is. That's where this multiple comparisons table comes in. Notice that this is listed under the post hoc tests. So this table is, I first introduced this to you in the PowerPoint. I'll share a little bit more about what's happening here. Remember that this post hoc is saying, okay, well, analyze the specific significance between those with no high school and those with a high school GED. Is there a significant difference between those? In order for us to determine that, we're going to look at this significance level. You're still comparing to 0.05. If we compare students whose GPAs, the GPAs of students whose mothers don't have high school to the GPA of students whose mothers do have a high school degree, there is, according to this significance level, a significant difference between those groups. So we find significance between no high school and high school GED. We also find a significant difference between no high school and having an associate's or certificate, as well as no high school and having a bachelor's in arts or a bachelor's in science, as well as a significant difference between those who have no high school and who have a graduate school education, because 0.032 is less than 0.05. So this means that when comparing specifically no high school education to each of these other four groups, we find significance between all of them. As part of writing your results, you want to make sure that you identify that there is significance between all of these groups in the way that is being presented to you. For the second section down here, this is SPSS now saying, okay, I've already compared no high school to all the other groups. Now I'm going to compare high school GED to all the other groups. This first comparison is the same comparison that we have between no high school and high school. It's flipped them because it's now leading with the high school GED. But what that means for you is when you're writing up your results, you don't need to reference this same significance again. It's already been done. As long as you've reported it once here, then you're good to go. You don't need to report it again. So now your focus becomes, okay, let me compare high school to associate's or certificate. This 0.974 is greater than 0.05, so there's no significance here. There is significant difference between high school GED and bachelor's degree with 0.018. So this, you would report on this. You would include this as part of the results, reporting results. There is not significant difference between high school and graduate school. When we move on down to the next comparison, the next comparisons, if you will, between associates or certificate and no high school, there is significance, but again, we've actually already identified that here in this first comparison. Between no high school and associate certificate, we have these same values being represented, so we wouldn't represent this one, we wouldn't present this significance again. There's no significance between associate's degree, high school, GED. We actually learned that in the previous section, but we can, since there's no significance, we don't need to worry about reporting it anyways. We have between AA and BA, and there is no significance, and between AA and graduate school, there's no significance. For BA, compared with no high school, still significance. We've already seen this, so we don't need to report on it again. Between bachelor's and high school, we've already seen that there is significance. We learned this in this second set of comparisons, so we don't need to report on that again. Between bachelor's and associates, there is not significance. Between bachelor's and graduate school, there's no significance. And finally, by this last comparison, graduate school to no high school, yes, there is, but we've already reported on it previously. And then there's no significance for the rest of these categories. So that's it. That's what you need to make sure that you're reporting on in your reporting results section. Make sure you pay close attention to the way in which I've framed and provided the outline for the One Way ANOVA. You want to use that first couple sentences to say, yes, there is significance or there's not significance. And here are the results of our ANOVA test. I'm going to include some information. I actually don't have a way to write on the screen. So bear with me as I explain this, which is when you are looking at the prompt or the outline for the one-way ANOVA, you have those first two sentences, and it's within those first two sentences that you report on significance. And then you can see that little formula that says F, open parentheses, number, comma, number, close parentheses, so on and so forth. So let me point out to you where it is that those numbers are coming from. So F, the capitalized and italicized F, that is, you report that exactly that way. And then you're going to do an open parentheses. That first number before the comma is your degrees of freedom between. So if we were reporting on these results, it would be 4, comma, space, and then within group, so that would be 889. You would close that parentheses, place an equal sign. The next value is your actual F statistic. So you would report 13.10 because we want to round to 2 decimals, but this 5 means that our 9 should actually be moved up to 1. So we would report we report equal signs 13.10 or 13.1. And then you'd write a comma, an italicized P, and then less than 0.001, because that is the probability that the probability associated with this F statistic that SPSS has calculated for us. So think of it as a formula, just as I introduced it to you the first time with the t-test. So follow that same formatting. All right. So that's all I've got for this. You want to do your ANOVA analysis a total of 2 times, 2 separate analyses. You are welcome to choose, whichever variables you'd like to include. Again, just please don't use this same combination of mother's education level and GPA. If you have any questions, make sure you reach out.